So our final presenter today then is Forrest Senti from Intelligent Payload Solutions, speaking to Embedded Credential Protector for Frontline Credential Verification. Forrest?
All right, thanks, Chris. I'm gonna go ahead and jump in here. All right, my controls. Sweet. Well, happy Wednesday, everybody. My name is Forrest Senti. I'm the Vice President of Product and Partnerships here at Intelligent Payload Solutions. We're going to be talking about the Embedded Credential Protector. We also call it Totem internally. So if you hear me say ECP or Embedded Credential Protector or Totem, these are all the same products. We just like to, in marketing land, we always like to name things, different things for different applications for fun. So just going to go ahead and jump right in. So when we talk about our problem, one of the big things we like to focus on is there's this growing issue around counterfeit documents. Physical and digital documents, generally speaking, more recently are becoming more and more susceptible to things like artificial intelligence or advanced software programs. One of the more recent ones is things like photomorphing, where you get somebody like me, you get somebody who looks similar to me. They take our two faces, they create a face that's kind of, in the middle between the two, and they submit that with their passport application that's able to sometimes get through some of these systems, and they can use that to travel. So that's a new one that's become a problem. And then when you layer that in, you continue down the rabbit hole of things like inefficient, insecure verification. A lot of the authentication methods we go through today that are away from connected systems can be slow and lack redundancy. Physical checks or simple scans, those types of things. Those things now are easily beaten, especially when you're looking at scanning things like a PDF 417 on the back of a driver's license. A lot of those systems can be insecure or inefficient or lack the complexity to actually detect if a credential is fake. When we go beyond that, when we look at things like traditional access control systems or limited mobility and mobile authentication, a lot of the things that stand out to us when we look at the market, broadly speaking, from problem set, is there's two things that stand out to me. One, rapid flexibility and the ability to revoke credentials on the fly, being able to cancel a credential. Whether that's a temporary one, a worker one, employee badge, driver's license, etc. The ability to revoke is very difficult remotely. And then when you layer that in with the ability for, say, somebody in the field, in the middle of nowhere, working in kind of abject conditions, it can be really difficult. So that was kind of our problem statement when we first engaged DHS in the SBIR program. That's what we were heavily focused on. So in terms of organizations that might benefit, just to give you a couple examples to kind of bring your head to a place, to a common viewpoint, as you will. One that really stands out for us is like U.S. Border Patrol, the ability to do mobile authentication of identity at any location. If that's something of interest to you, that should stand out. On incident responders, we had some conversations with like some of the folks in the emergency management community, and one of the interesting things to us that stood out was the ability to identify which volunteers have what certifications or what types of training or what types of licensing do they have. Whenever those emergency management scenarios get stood up, there's always kind of a checkpoint where you're kind of in processing everybody and making sure you get all the right information and right materials going on. So if you have issues with that or you want to make that a little easier, we have some interesting things I'll talk about later about that. Things like rapid ID authentication, connections to other certificates, other records. If that's something you're interested in doing, that's the kind of work that we're interested in, we can help with. For TSA, things like domestic international surface aviation operations, mobile application verification, rapid ID authentication, those are areas that we can support. Beyond that, just to kind of close this out, installation access, restricted area access, controlled document security for the federal government. We actually are working now with the Air Force Academy on a similar project in this space, where we're working through things like temporary badging, prescription pickups, parking passes, and I'll kind of describe some of those systems later. And then the impetus for everything for us is all around driver's license and critical document protection. That's really the basis of kind of where we come in and where we were envisioned to support, and that's kind of the main purpose. But just for fun, we always like to talk about check fraud, and you'll understand why when I get to it later. So just to kind of, again, to orient you in terms of baseline technologies, a vast majority of people in the corporate and employee world use a standard polycarbonate card, like you would see at a grocery store, or like that you have your gas station rewards program. It's just a simple card with a simple scan with a simple bit of information on it. And all it's doing is giving you the ability to quickly do something. When we layer beyond that for more advanced use cases, things like EMT licenses or driver's licenses, continuing on past that to things like passport cards, CAT cards, all these different things, you start to layer in different elements in there, things like microprinting or UV or barcodes, NFC tags, all these different things. But each one of these individual technologies creates additional layers of cost. When we look at things like the NFC tag specifically on a CAT card, for example, those things burn out, and for people that use them often, they can replace them as often as every 6 to 12 months, which increases the cost associated with some of those things. So when you look at that and then you layer that in with things like limited external connections or the narrow use for badging outside of the designated region, no portability or usability for a driver's license, for example, those are other problems that come out that stand out to us when we're looking at this. Let's get back one, sorry. And so that's that. So one of the things here I want to talk about is this idea of a desired value proposition. So one of the things when we were working on this presentation that we were thinking through was, what would an ideal customer look like? These numbers don't come from the government. These are our numbers. These are just examples of the type of help that we could do in an area like a Flightland or a TWIC access or things like visitor contractor access. And what stands out here for me is that what we're really good at is helping with things like a failure rate for certification or training authentication, or reducing things like access time, because we can increase the level of trust to a credential and accelerate some of these things to get people to what they're trying to do, which is their jobs ultimately. On top of that, when it comes to issuance, and again, I'll talk to a little bit more about this later. For us, it's relatively quick. We don't change any or add a gigantic amount of complexity to the issuance process when you're actually giving people some of these badges or licenses or these types of things. And then on the second part with things like visitor and contractor access, a vast majority of people, when you go into even a government controlled building, you get a guest badge that has a number on it and is tied to a driver's license that's written in a logbook. That guest badge doesn't necessarily say where you can or cannot be or a room you're not supposed to be in. And it's those types of things that we could help with, specific to things like background verification, rapid scanning, being able to check if someone's out of bounds. You can also layer that in with stuff like behavioral analytics, where you can tell if somebody who was just scanned for being in an area is in the wrong place and kind of identify some of those things. So then we'll jump in. So now let's talk about where the magic happens. This is the ECP, the totem product. So what we're doing is we are ultimately taking information on a standard credential. In our case, this is a fake driver's license that we produced. Don't crucify us for it. We promise we're not going to any bars or anything and trying to use these. But one of the important things here is that we're able to take the information on a card, turn it into a string of data. We do a one-way encryption that can't be recovered. And using our totem product, we're then able to take that information and covertly embed it into images or graphics. So in this context here, what we're doing is we're taking, available information, encrypting it, and then embedding it into an image. And then that image is then used as the actual, in this use case, a driver's license image. Then once it's on there and it's issued and somebody physically has an ID, we have multiple different ways that we can then go about verifying that ID or creating verification flows to help with that. So if you come down here, we have an iOS app built out. We have a web application built out that's easily integrated with several other products. And then we also did a test run that actually worked really well on the original CAT scanner from TSA, the M500. And all of those, what they're doing is that you're taking the credential and you're able to put it into these systems or to get it scanned. And what it's doing is it's taking the information on the driver's license, it's pulling that PDF 417 and the barcode in the back of that ID, and it's actually going and finding that image on the driver's license with the totem stamp inside of there, and it's connecting the three of those to say, yes, thumbs up, this is a legit verified ID, and we can authenticate that nothing on this has been changed from when it was issued. The reason why this is important is it helps battle against things like photo morphing, name changes on an ID, people trying to swap different things, or things like credential sharing and those types of things. Some of the cool things we can do beyond that are things like location data over time. In that embedded information that we can put in an image, we can actually put things like a certification pointer. So things, so say you have an EMS certificate or something like that, we can actually put that into a stamp so that when you show up to something and all you have to do is present your driver's license, they're able to pull that information off of there to make it happen. In addition to that, we've also talked to people about things like electronic systems access, and that's something we can do as well. So to give you an idea of kind of what an implementation would look like and kind of how we actually go about doing this, really it's designed to lay into the printing process on the front end, and then on the back end, there's a verifier that we work on. So your standard issuer, somebody comes up, they request an ID, they give all the information that's relevant. The issuing authority, confirms this person is able to get an ID, and then our software essentially is an API that layers into the printing process. So if you have a standard printer with any piece of software that's kind of attached to it, we can layer in there. So when you generate that image of a person, it passes through our filter with whatever data you want to assign to it, and then just comes back to you as part of that process to the continued printing. And once you do that and give it to them, what's happening in the background is there's a lot of other information that's going on. We're able to do things in a more complex system, like create a DID, a decentralized ID, that exists in the digital realm that can go out and point to other systems and make sure that, somebody is able to be in room A, B, and C, but not D. They've got these 3 certificates and these 3 licenses, or even beyond that to do things like, things like location data or all that kind of stuff. On the verifying side, when somebody comes and they bring their ID and they present it to a verifier, all that's happening on this side is that somebody who has the authority to be a verifier has access to the app, the web app, or some type of scanning system that's then verifying the ID. One of the things we're working on now is the ability to actually layer in facial recognition so that we can actually verify that the person holding the credential before they present it is actually the person who they say they are. So we're doing things like matching, say my face to the credential that I'm holding, and then verifying that the information that's on that ID hasn't been changed so that all 3 are in sync. And the interesting thing about all of this, in my opinion, as somebody who, quite frankly, is a technology nerd, is this is all just printing. There isn't any special inks. There's little to no specialty processes. Really, the whole goal of this idea is that we can have a massive increase in security and create new ways to connect your typical physical credential, things like online different pieces or mobile or different pieces. But it creates this connection where it's inexpensive and you don't have to spend as much money on these crazy inks or printing processes or fancy things. So in terms of just general performance features for you to think about when you're thinking about our product, covert is one piece that's really important. It's very difficult. It literally just looks like a smudge when you look at this. It's not obvious to the human eye that this is something that is holding data or is capable of getting into different rooms or that kind of thing. On the personalized front, each one of these is uniquely different. No 2 are ever the same. So nobody is ever going to be able to take one that's made for person A and use it on person B. It will always be personalized. On the security side, one of the things we're working on now is we're creating some relationships with universities to test this. But the core meaning behind our algorithm that we built for this is that it's not able to be decodable with public tools. The encoding side of this would be incredibly difficult to reverse engineer without a massive amount of compute, and it would probably take years to figure out the encryption side to actually break it, to get into it. So in terms of safety, in terms of privacy, it's very strong, and it's something we're really proud of, and we're happy to talk more about that if anybody has other questions. And these last 4 that I'll speak to real quickly, things like independent. We have a long history in being able to work with people on customizing, and we've built like different API integrations and different software for like folks here in the state of Colorado and other places across the country. So we're very good at working with people on specific parameters or figuring out flexible options or different things like that. So we're very good at that. And then on the connected and unconnected side, and the unique element, one big thing that I just want to say that stands out here for me is everything we're talking about, you can do offline. The verifying, all that kind of stuff, you don't need an internet connection to be able to test something, because all it's doing is the model is specifically training to make sure that something is verified and it's real. So it doesn't necessarily need to go out to any kind of a cloud service to actually run any kind of program to do it. It's all on board. In terms of generally speaking, our competition, Idemia is the one that's the main player in the space. And those types of, and that's the main player that we focus on. But the biggest thing with all the other players, Demia, Thales, GSD, De La Rue, is they have a big focus on the physical security of the credentials. So they're doing lots of different printings and inks and specialty printers and all this kind of stuff. But that's not where we lay in. So anybody who's focused on a driver's license use case or any of these kind of credentialing use cases, we provide an inexpensive option that's easy to use to increase security. And in terms of current state of development, I mentioned this earlier, but we are a demo-ready product. These are all the different pathways we went through during the SBIR program. We finished our SBIR a few months ago, so now we're in that post-SBIR lull. Well, not a lull. We're actually really excited. But we're at the stage where we're able to do demos for people and work with people on implementations. In terms of commercialization, what we're looking for here today is, one, we're seeking non-driver's license use cases. Two, we're heavily focused on increasing our core functions and our capabilities for more market opportunities. So the facial recognition piece is something we're working on in the Air Force Academy. We're really excited about it. And then the last thing there is we're working on building more channel partners for sales. We are not the be-all end-all solution for identity security, but whenever we can work with a partner like a Deloitte, or in some cases like an Ademia, we can go and we can meet that need. Last things I'll say here, and then I'll close for questions, is in terms of our engagement goals today, we really want to hear from you if this is something that's interesting for you that you could use, and if there's specific needs that you have for the first round of the community that we can meet you at. And then the second piece of that is what use cases would be the most ideal, because we'd love to work with you on those. So in close, IPS is a company that's been around for about 18 years. We have a long history of being able to do these types of work, and we love developing new products for people and scaling those for growth. So look forward to taking your questions, and thanks for having me here today. Thanks, Chris.